Hello, welcome to this lesson. I am excited to connect with you again. This lesson is going to basically be about oxides, and on the screen there you can see some beautiful pictures of colored oxides. Oxides are really very beautiful things. You realize we have here various colors. I don't know whether you can tell which one is red, which one is which color. Please make sure that you are able to identify the colors. A little bit of the guiding on the colors. Which oxide is this? This oxide, this compound here is green in color. Can we all see that? And this is yellow in color. And this one over here is black in color, and this is red. Okay, and what is this? This is brown, and this is also brown, although this is dark brown. And then this is blue, and lastly this is orange in color. Okay, so those are very common colors in chemistry, and all this you see here are colors of oxides. Doesn't mean that anything which is of this color is really an oxide, no. But oxides also have such colors, depending on which oxide it is. Okay, good. Now, some little bit of the identification. We look at black oxides. We have some oxides which are black in color. We have some oxides which are brown in color. We have some that are green in color, some are red in color, others are blue in color, others are yellow in color, others are actually colorless. So there are a variety of oxides out there. Now, depending on their physical states, oxides can also be solids. We have solid oxides, which are basically, solid oxides are basically oxides of metallic elements. Then we also have gaseous oxides. Gaseous oxides are oxides of non-metal elements in most cases. And most of the non-metal oxides are actually gaseous oxides. Then we also have liquid oxides. Liquid oxides are oxides of non-metal elements, but a major example of liquid oxides is water. The one you take is an oxide of hydrogen, which is a non-metal. Okay, now what is an oxide? What is this we are calling an oxide? An oxide is basically a compound which contains oxygen and another element. So you have oxygen combined with another element. That one is called an oxide. For example, we have a compound here which is called calcium oxide. The elements in this compound are calcium, which has the symbol Ca, capital C, lowercase a, and oxygen, which has the formula, the symbol O, that is oxide. Okay, then we also have carbon monoxide. This is carbon monoxide. Carbon, it has elements carbon and oxygen, one oxygen atom. That's why we say monoxide. Okay, then we have others, magnesium oxide, which has magnesium and oxygen. All those are oxides having oxygen and another element. We already talked about oxides being of various colors. You have seen all those colors and various physical states. And when they are solids, when oxides are solids, they have a variety of colors. All these, when they are solids, you can see that all these are solids. Okay, but when they are gases, usually the colors are a little bit limited. Most of them are colorless, although some are also colored Okay, for example, you realize that nitrogen dioxide is brown. Okay, then when they are liquids, you know the color of water. Water is colorless, right? Very good. Now, we already talked about this. Some oxides can be gases, which we said are mostly non-metal oxides. So most non-metal oxides are gases. For example, carbon dioxide, sulfur trioxide, sulfur dioxide, nitrogen monoxide, carbon monoxide, nitrogen dioxide. All those are non-metal oxides, which are gases. Okay, then others can be liquids. We already talked about water being the most common liquid non-metal oxide. Okay, good. Now, oxides can be basically classified, can be divided into four major types, four major common types. What are they? We have basic oxides. Basic oxides. These oxides are oxides of metals, meaning that they are actually made from metals and oxygen gas. Okay, so when you have a metal combined with oxygen, the oxide formed there is a basic oxide. Okay, and these oxides are in most cases solids. We said all metal oxides are actually solids. Okay, at room temperature. Okay, so these ones are metal oxides. Then we have acidic oxides. Acidic oxides have a special name, which is acid anhydrides. This name is specifically for those acidic oxides which can dissolve in water. Okay, so this is acid anhydride are oxides of non-metals which dissolve in water to form acids. Okay, so not all acidic oxides are acid anhydrides. Some of them do not dissolve in water, therefore they are not acid anhydrides. Okay, then we have amphoteric oxides. Oh, before we go to amphoteric oxides, we have these acidic oxides are actually non-metal oxides. All of them are non-metal oxides. Then we have amphoteric oxides. Amphoteric oxides are also metal oxides like basic oxides. However, the amphoteric oxides are oxides of metals which are closer to the non-metals in the periodic table, like we shall look at. Then we have neutral oxides. Neutral oxides are oxides of non-metals, but these neutral oxides do not behave like acids. They don't also behave like bases. They are actually totally different from acids and bases. Okay, so they are neutral. They don't have any effect on litmus paper. Examples of this include water, which is an oxide of hydrogen, include nitrogen monoxide and carbon monoxide. Okay, so in the periodic table where you see metals, then you must suspect either basic oxides or amphoteric oxides. Like you can see here shaded purple, you realize that all these that are shaded purple are basic oxides, all this. Then close to them there are non-metal, rather they are metals which are close to non-metals, so they form amphoteric oxides. Okay, then after that you have non-metal elements. These non-metal elements now form acidic oxides. Okay, however,